All right, well, welcome to another episode of the Inside the Scholar's Journey podcast. My name is Pat Nana-Sinkam. The goal of the podcast is to both educate and hopefully inspire those of you who are navigating their path toward a career in biomedical research. Along the way, we plan to have a few special guests on the podcast, and today is one of those days. It's my pleasure to welcome Dr. Arun Sanyal to the podcast. Dr. Sanyal is an internationally recognized physician scientist in the field of hepatology, particularly metabolic dysfunction-associated steatotic liver disease, or MASLD. He's a highly respected mentor and administrator, including serving as chair of the Division of Gastroenterology, Hepatology, and Nutrition. Most recently, through a transformational philanthropic gift, he assumed the role as the inaugural director of the Stravitz-Sanyal Institute for Liver Disease. Importantly, this institute represents a few of its kind, whose goal is to integrate clinical care with education and translational science with an ultimate goal of bringing leading-edge discoveries to our communities. Arun, welcome to the podcast.
Thank you, Pat. It's awesome to be on this.
So thank you so much for being here. I can really speak to the fact that it's been an absolute pleasure to work with you, and I know how busy you are, and I so appreciate your willingness to join us. I thought we would jump right in with a question about really your own career path. Interestingly, one of the first episodes that we had for this particular podcast was talking about this concept of research niche, really figuring out where you're going to make your mark. This is important for young investigators. Sometimes it takes them a long time to figure out where they're going to eventually land, but we all recognize that's important to being successful eventually. So as you kind of reflect on your own career, what would you say really drew you to liver disease, and why did you decide to stay on that path and make your mark in that way?
You know, Pat, I've actually thought about that quite a bit over the years, just reflecting back on my own personal journey. And actually, it really goes back to three different things. One is to recognize yourself and what drives you, and being conscious and aware of your own personality traits, with all its pluses and minuses, because it drives who you are and your motivation and what you want to do in life. Number two, there is chance in life. Destiny sometimes has to smile on you and guide you. And instead of fighting destiny because you have a predefined script in your head, sometimes you allow destiny to be a catalyst along the journey. And then once you figure out your direction, then the strategic thinking comes into play as to figuring out what is the nature of the research you want to engage in and what you actually want to do. So personally, I was always, as a kid, I was very scrawny and frequently got beat up in school. So one thing I learned was I was afraid of backing down, because I always felt if I backed out of a fight once, I would spend the life and the rest of my life running away from problems. And I don't know where that thought came in my head, but it's been there probably from the fourth or fifth grade. And it has stuck with me and defined who I am as a person. So I'm a little scrappy. I mean, that's the short answer. So that was part of it. So hepatology scared the dickens out of me when I was a medicine resident, because these patients were so sick. And at that time, there were virtually no therapeutics for liver disease. So these patients would come in and you would watch them and be part of their final journey. And it was really frightening. And so instead of running away from liver disease, I jumped into liver disease. Second was Dr. Vlashovic, who was one of my mentors. He called me into his office one day and said, I really think you're suited for liver disease. You should do liver disease. And we didn't spend a huge amount of time talking about various things. I trusted him. And so, mentorship is very important. And so it was a combination of those two things. Now, once I entered the liver field, some of it again was pure chance and intuition that I figured out the right places to be at the right point in time. But the things I would say is you have to keep your eyes and ears open to unmet needs, and also to work in an area where there's enough that is not known that you don't end up doing a series of one-off projects. Nothing hurts a career early on than to be engaged in dead-end projects where once you finish the project, there's nowhere else to go. You finish the project and you have to start a whole new project. So it has to be an area where the gap in knowledge is important enough that it meets the who cares question. And then number two, that when you answer a finite question within that space, it helps you then move to the next question and then the next question after that, so that after a period of time, you have a hierarchy of data that have come out that start building a bridge across this gap in knowledge, which then you are sort of the champion, authority, and leader in. And that's how you build a career.
It's interesting you talk about the gap in knowledge because often when we are training early career investigators to write their specific aims or how they should go about giving a scientific presentation, we always try to ensure that they have that theme of gap in knowledge. What is the gap that you're filling? I think you would agree that now that gap in knowledge and filling that gap in knowledge is being articulated as impact. And what is the impact of the work that you do? I don't think that any of us who've been doing this for a while can sit in a study section and not hear the word impact brought up a multitude of times. What is the impact of the proposal? What is the impact of the line of investigation? I think many young investigators struggle with how to truly articulate the impact of what they do. So as you're thinking about not only your own science, but you're thinking about when you're vetting the science of a young investigator, do you have any type of framework that you use in your own mind to try to decide how close a line of investigation might be towards being impactful? And importantly, how do you decide we should go this direction versus we should go this other direction because this one's not impactful, this one might be impactful?
So I have almost a formal process for doing this. And that process involves first, not only just asking what is not known, but really going even prior to that to identify a state of dissatisfaction with the status quo. So if our patients are having poor outcomes or they have decreased access to care because we don't have a diagnostic tool or an easy way in the place where the patients live, where they're being identified, you find a problem that is relevant and is a barrier to progress and something, and to be able to articulate what that problem is and why it is a barrier. Why is it a problem? So a problem is a state of dissatisfaction coupled with the desire to make it better. Because if you have no desire to improve, it's not a problem. Life goes on. So you put these together and you have to be able to state in one or two sentences why it is a big deal. Why are patients and society suffering? It's not about you and what you know or you don't know. It's about the people we serve. We are doing the research to improve the health of our patients. So we have to define that gap. And then we say this barrier, this state of dissatisfaction exists because we don't know A, B, or C. And then if we can figure out a way to answer A, B, and C, this is how the world would change. And so it's really a three-step process. And if we can identify something that is a huge problem for patients in terms of how they feel, function, or survive, which is what is clinically meaningful, or whether they have decreased access to care, or something that from a societal perspective, from the individual perspective, is a big deal, we can articulate that and we can say, what is it we don't know that is preventing this from being in a better place? And then to say, now we're going to come in with an idea or a series of ideas, or this is the place where we want to build a career, and our starting point is going to be this, because by answering this, we will then go to the next set of questions and over time be able to bridge this. And this is how the world would change by doing this. So I think this has to be really, a lot of time goes into actually being able to think through this to make sure that the what if, why would anyone want to continue to read your application once, and if you lose them at this point and people say, yeah, it's cute, but, it ain't going to change nothing. So then you've sort of already lost your reviewer, you've lost the game at that point. So that first paragraph is so critically important in that specific aims page. because it also helps. It's a fantastic process because it helps crystallize your own thinking. Because, as we start, there are multitude of thoughts whirling around in our head, and it's a little loosey goosey. But then, as you start putting words on paper and articulating, you start focusing it down, so you actually know where you're going to focus. Because there may be a problem, and you can attack it from 10 different angles, but you have to define why you're picking the angle that you're picking, and why it's your starting point, and why not the other approaches. So you have to really think through all of this. So that first page is so critically important, because if that is done well, I think the rest of the grant sort of writes itself in many ways.
So that's interesting. We have the research niche. We have what we think is probably an impactful idea, but now we need what many of us refer to as the actual fuel that you put in the engine, and that is the funding, the support. It's no secret that academic research faces a lot of challenges, one of which is extramural funding. And it seems as if over time, to the last 20 to 30 years, um, research funding has become more challenging. And I think we know that. And that's created a significant threat on the pipeline. And it's actually forced many young investigators to reevaluate their strategies for supporting their research. Some have taken the approach of completely redirecting their goals. For example, moving from saying, I'm going to be independent to, I think I'm going to be part of a larger research team as a co-investigator. And sometimes that results in writing many, many grants, joining many grants as a co-investigator, in which case sometimes you risk losing your focus of your work, the work you want to do. Many are turning to industry. The Stravitz-Sanyal Institute was very fortunate to have philanthropy, which I think increasingly is essential to moving the research needle. How do you think about advising young investigators? How have you evolved in terms of your own thinking about funding to do the research? How do you approach that at this point?
I think it's a complex issue, obviously, because dollars and cents, as you know, are tight. And the first and foremost, you have to have protected time if you want to develop your own independent body of science that becomes independently funded and that you can maintain funding. Number two is you have to have some resources to generate the early data that allow you to go for funding. And so those are your primary needs early on. So having mentors who can help you, at least with funding, access to resources and technologies, etc., early on is really important. But you also need institutional support. So you're not spending your time worrying about how you're going to pay your mortgage next month, and you're focused on getting your work done. And that requires, that is something that the individual investigator cannot solve for themselves. And that's where the institution comes in. And, we're, I suspect, going to see an evolution where institutions that have a diversified portfolio of funding sources will be able to weather the storm when a storm arises much better than those who are solely reliant or primarily reliant on federal funding as their principal source, which was the classic paradigm, that your funding all came from the NIH. You did a little bit of industry research on the side. But I think increasingly what we're finding is some of the most transformational things in medicine are coming from public-private partnerships. So one of the things we do in our institute, and I think probably would be interesting and good for many others to do, is to engage more broadly in public-private partnerships. Again, historically, these were considered to be sort of dirty money. If you were working with private entities, somehow that was considered not high quality science, that you were looked down upon. But the cure of hepatitis C, all the progress we've made in metabolic diseases, the GLPs, all of these have emerged from high quality public-private partnerships, the advances in oncology. The big things are moved not just by industry alone or by academia alone. But when they come together within ethical boundaries, you can do amazing things. So I think diversification of funding sources is critical. And philanthropy is a major bucket, but public-private partnerships, working with biotech, who have amazing technologies in terms of technology and innovation with technology. There is so much happening in the biotech sector that I think, again, active engagement with the biotech sector and having the connectivity to talk to people in that sector, because they are also looking for academic partners because they don't have the patience. We have the patience, we have the content expertise, they have the technology. When we come together, we can do amazing things. I think those are some of the solutions. They may not be all of the solutions, but philanthropy is one, public-private partnerships is another. There are a lot of other foundations and other sources to support. Many of the professional societies have small early career grants to get people going with their preliminary data generation. So it really behooves an early investigator to work with their mentor. And it's part of the mentor's responsibility also to guide the young investigator in terms of what these options, what portfolio and menu of options may be available, so that they can make the best use of these options. And sometimes you can take the same application and turn it into multiple places where they may apply. And then when you get one, you can tell the others that I already got my funding, because, it's probably not kosher to, take grants from two different sources to the one with the same project. That's called double dipping.
Yeah, of course. And as we think about really positioning our young investigators to be successful and position them to pursue science that is truly keeping up with what is a rapidly changing field, I think any of us in positions of mentorship would be remiss if we didn't ensure that we at least introduce data science and AI and machine learning into our mentees' portfolio. I think it's clear that AI and data science and machine learning are shaping drug discovery. It's shaping diagnostics, even how we deliver care in a more efficient manner. So for us not to start to think about how to integrate those important platforms, I think would be doing a disservice to many of our young investigators. How are you currently using some of these tools and platforms to shape discovery in those with liver disease? And how are you encouraging young investigators to really lean into this field moving forward? It's true that it's a younger generation, so in many regards, they're ahead of us, right? But even those who are doing preclinical work should be thinking about, well, how does data science fit into this, all the way up to those who are clinical trialists?
So I'll start with the last piece first. So whereas historically we started in the laboratory and translated our laboratory research into preclinical models, from there into first in humans and up the chain to advanced human trials. What I have always done, and I started by doing this before the word translational science really existed, because I've been around a long time, did it by intuition. I don't know, it just seemed like the right thing to do. But that was mainly because I was a physician, and when I was doing science, I said, if I was going to do pure science and forget about what I'm doing at the bedside, I should have got a PhD alone and be done with it, as opposed to this long, arduous path that I've been on. So I let the patient actually be my teacher, and the patient to tell me what research I should be doing. So when the patients tell me they're having a problem with something, and I'm asking myself, why can't I fix this problem for the patient? Why is everything I'm offering this patient not solving the problem? Then that I know that's a problem. And when that happens again and again and again, then I intuitively know it's a big problem. And the more people who tell me that, this is a problem for them and I'm unable to solve it, then I know the magnitude and the scope of the problem. So that has always been a great guide for me. And then I've reverse translated that problem. So I take that problem and say, now, if I go back to the lab, how do I start solving that problem? So I think the reverse translation is a very important concept, that both forward and reverse translation should be part of your approach and paradigm as to how you solve big problems in the medical world. Number two is what I have done is, since our focus is looking at the health of all the organs in the body through the lens of the liver. So our core hypothesis is that the liver plays a central role in integrating the metabolism and function of all the other organs. So if the liver goes down, all the other organs will go down. So we have a longitudinal cohort study, and where we collect, deeply phenotype the patient, but at the same time collect biosamples. So we have, we can get all the different omics, in a very unselected way at these pre-selected time points. In between, we are collecting clinical outcomes. We have put through a biorepository IRB protocol, which has, a consenting mechanism where if the patient signs the consent once, every time there's leftover blood after routine lab work, we can collect those samples and bring them to the lab. So we're building our biorepository case, and that biorepository is really critical because it helps now support the research of many different groups of young investigators. And because we are deeply phenotyping what's happening in the brain, the heart, the liver, the pancreas, the muscle, the kidneys, everything, then for those who are interested in liver-brain crosstalk, we can extract that data and get it to them for analysis. For those who are doing liver heart, we can get them the appropriate data, because if somebody wanted to look at all of it, we could pull it all together. And this allows me, through one study with one coordinator seeing the patient, instead of 10 coordinators descending with 10 different consent forms on the patient, one consent form, one patient, one coordinator, but we are collecting all this information that is supporting career growth of 15 different investigators. So one study to launch 15 careers, which becomes very resource efficient. Then, of course, we're collecting a lot of data. So that brings us to data science. So we've, of course, invested in people who can, and when we think about data, from infrastructure point of view, there's hardware, the actual computers and the computing, then there's software, then there's data security access, data integrity, then there are data analysts who can actually pull out the information from this huge amount of data that's sitting in those hardware, and then you have data scientists who are analyzed. So you have to, it's more than any individual young person can do, or even a division can do. It's an institutional, this infrastructure has to be core to what every forward-looking institution has. And because you require all of these different phenotypes of people to be able to provide the data science support that is needed. Now, what we are doing with our infrastructure is building this liver atlas, because we will have all the omics and the phenotyping, and we are longitudinally collecting outcomes with pre-specified case definitions, so that we are collecting the source data at the time those things occur. So essentially, this will create the platform for precision medicine going forward. And we are working towards using what we call quantitative systems pharmacology to be able to combine all of this to create a digital twin for our patients, for in silico modeling, etc. All of these now provide, through one large project, master project, you talk about master trials to answer multiple clinical questions in one trial, but we have one trial to launch the career of, this is a master trial to foster the career growth of a small army of people. And so that's sort of how we're approaching it, so that we are using the data. And again, we are using public-private partnerships, because there's a lot of expertise out there in the biotech sector with data science and innovations in how you work with data. Of course, the key is managing the data transfer agreements. There are some regulatory issues and compliance issues that you have to work through. We're also working a lot with technology. And as you're aware, we have a project now using a technology platform with the long-term goal of using the data that we're going to get to develop a technology-based way of managing liver patients who are on the transplant waiting list, to identify problems before they occur. Our goal is to develop predictive algorithms so we can identify who will have a problem before they have a problem, so we can keep them out of the emergency room and the hospital and manage them proactively rather than reactively, where the outcomes are. So over time, and as you know, just very recently, the CMS just announced an entire new program to support and model how they would fund technology assisted care of chronic medical conditions that hopefully we will be able to go in as one of the initial first wave of institutions to model this. So I think we have to be aware of what is happening around the world. We have to be proactive, and you have to be brave and willing enough to take a chance institutionally to jump in front and be part of the change and not follow the change.
Yeah, absolutely. And I'm so glad to hear you, talk about the institutional role in all of this, because much of what you're describing, particularly with the project that you and your team have been working on, really falls under the umbrella of the learning health system. The idea of data directly informing knowledge, and then the knowledge directly informing the performance or how you care for the patient, which then creates more data. In this case, it would be in liver patients, and it's an iterative process, and you keep going back through and through until you identify the ideal way to care for those patients.
Exactly. And at the tail end of this is our care pathway, which we call MET 360, because it's a 360-degree assessment of metabolic health, and not just based on organ-based care. But we also there build in ways to assess at every step whether the patient journey and the physician journey are being aligned. We talk a lot about patient journey, but there is a physician journey also, because sometimes physicians have pardon my language, oh no, kind of moment when you diagnose somebody and you feel, I'm a little out of my depth here. How am I going to do this? And I think these are areas for research where technology can really come in. So there's so many opportunities, from basic discovery, preclinical models, biomarker science, which is now really evolved into a whole science in itself. A lot of people talk about biomarkers, but the bulk of biomarker research, as you know, is very low quality. So I think institutionally, we must invest in training the new generation of investigators about best practices in biomarker research and biomarker science. And then, of course, regulatory science to understand how all this comes through regulatory pathways to the market, and then access and policy.
So let's talk a minute about our next generation, our young investigators, and a topic that it's really top of mind. It always has been, but it seems as if it's certainly much more top of mind, and that really has to do with the work-life balance and work-life integration. We can refer to that. There's an increasing recognition, particularly that young investigators are really balancing long hours, particularly if they happen to have clinical responsibilities, competitive environment, teaching, administrative duties, and most importantly, their family, and raising. In many cases, they're raising young families. That creates a tremendous amount of stress. It can lead to burnout, mental health issues among many of our younger colleagues. I know you carry very heavy load of responsibilities, and I'm honestly not quite sure what your formula is. So maybe you'll tell me afterwards, because I'm not sure what your formula is. But you manage to travel. You manage to spend time with family. I know that you like to hike a great deal, and I'd love to hear about where you last went, because I don't even know where you last went. But you like to hike with your family, and I know you're very passionate about that. What type of advice do you give your young mentees, particularly early on, when they're trying to establish themselves, so that in many ways they're at the highest risk of having an imbalance? We'll call it an imbalance, and really losing sight of what ultimately are the most important things in their lives.
Yeah, I think it's really important to be conscious and aware about what drives you. You got to know yourself first. First and foremost, you have to find some time for introspection, so you know who you are, what makes you happy, what turns you on. And then that passion should be, it is really, to be successful in anything, not just research, you have to be passionate about it. And just, we feel passionately about our family, we have feel passionately about our research. So then you have to learn how to compartmentalize that passion a little bit. And so one of the key is when you're working, be fully focused on working. When you're at home, be fully focused on the family. When you try to mix and match, you shortchange everybody. And in the end, you shortchange yourself. And that is the key. I find that's the most common reason for this chronic unhappiness that creeps in. So what actually worked for us, and everybody has to figure out what works for them. What worked for us is that Friday evening was always family evening. Friday evening and Saturday morning was, or one day of the weekend was for family, one day was for working. But I had an agreement, and you have to have a very understanding spouse. The secret to every successful investigator is a partner who gets it and is supportive. So I was very blessed and fortunate in having a partner. She was probably, I'm a little high energy in case you haven't perceived. So she was probably just as happy that I was out working rather than driving her crazy. But Friday evening and one day of the weekend was family day. And that I really did not touch the computer, did not do anything. Now what I do is I have cell phone free weekends. That there are few weekends, at least one weekend a month, from Friday evening to Saturday, Sunday evening, I will not touch the cell phone or the computer. I let my brain reset. We are getting so much input from so many sources. Uh, Between WhatsApp and my college group and my high school group, who all have found me, and it can drive you nuts. So I think everybody's brain needs a little cooling off time. Hiking for me is that zen where you can go somewhere where you're cut off, you're alone with your thoughts, and the only thing you hear is the sound of your breath and the wind, and you realize you're part of this larger world. And it's very humbling, but it's just very meditative. Meditation can be done in many different ways, and for me that's what worked. But really compartmentalizing, that when you're working, be 150% focused on your work, and when you turn it off, and you now with your kids, particularly with your children, I think it is extremely important that you are 150% focused on them, because the children do remember that when you're distracted, as I've learned, it has been pointed out to me. So, I mean, it's not like I knew right on day one what the right solution was. You have to figure this out. Some of it is, that's what's called life. You have to figure out how you navigate life.
Yeah, absolutely. Well, Arun, I really want to thank you for taking the time out of your busy schedule. It means a great deal to all of us. I know I speak for many when I say that we appreciate all you've done for future scientists, for your colleagues, and most importantly for our patients. Thank you so much. And of course,
It has been a pleasure. Absolutely. Thank you so much for having me, Pat.
absolutely. Happy holidays to you and the entire family.
Likewise.
And we'll see you
Likewise.
next time on another episode of Inside the Scholar's Journey. Thanks, everyone.
Absolutely. I look forward to it.